the goals of cloud native is to decompose, and it's both applications and infrastructure, move to a more stateless environment so that less state is maintained at any given time. Today, a lot of applications maintain state about the session or a flow that traverses throughout the network. In cloud native, a lot of the state is not maintained at any particular node or with any given instance of the application. It can be distributed throughout the data center itself. Very rapid life cycles, right? So one of the advantages of cloud, and if you look at a lot of cloud companies, is the ability that they have to quickly deploy new services, to quickly make changes to the application and push them out. Continuous integration, very robust testing infrastructure. Those kind of things is what cloud is trying to offer, right? So very quick changes and improvements in the services that you can offer. So, scalability, right? So instead of being bound to a particular node in taking could be weeks or months in order to deploy and scale out your infrastructure and telecommunications network or in your general networking environment. Being able to quickly scale up or scale down is the advantage that cloud offers you, right? It's what the Googles and the Facebooks of the world have achieved is the ability to quickly scale a service across their data centers, and that's kind of the objective that we like to see happen in telco or general networking environment as well. Lightweight, so the applications become lighter. Instead of a lot of dependency in knowledge of the underlying hardware or the underlying platform, the goal is to, what cloud applications kind of do is they abstract up to a higher level. So there's less knowledge of the platform in a cloud application. And so they become lighter weight, more portable throughout, and more portable. And it's not just the application, but also trying to push both the infrastructure and the application in these directions to try and improve the robustness and deployability of new services throughout the telco environment. Okay, so that's kind of like the impact. That's what's happening, what we're trying to achieve. So if we go back and we kind of look a little bit at the history, right? If you go to the left side of the picture here, you kind of started out many years ago with, that's where networking was. It's customized hardware, it's specific, achieves a specific function, and everything particularly came from a single vendor. The goal of NFV was to kind of move it away from, at least from a hardware perspective, to a more standard platform, and that's what NFV achieved, and virtualized the services so that they were easier to deploy throughout the network or throughout your data center. But the framework and the services, they still remained as a proprietary implementation, right? So the first step in NFV really was take an existing hardware appliance and the applications that ran on that hardware appliance and just really virtualize them onto a COTS hardware. And that's been successful. It's deployed very well. Now moving to a more intermediate stage before cloud is looking at things from the perspective of making them cloud ready, right? So instead of a virtual machine being all from a single vendor, in other words, the services that are infrastructure that's within the virtual machine or container from a single vendor, you now move to where you have a sort of mixed framework. And the mixed framework would be, could be part of it is custom or proprietary to a particular vendor, but really trying to produce frameworks that are, introduce frameworks that are generic and such that the service or the application that's there can utilize these frameworks that are more generic and be more portable across different types of cloud infrastructure. And finally, when you go into cloud native, right, the underlying hardware remains the same in terms of COTS and you move to an environment where containers or pods are the underlying base framework or the base infrastructure that's offered to the service. And then an open framework, an open standard framework that the service actually uses. I guess an example would be something like gRPC or something, a higher level communications mechanism, so that the underlying whatever transport that's there, the application doesn't need to be aware of it. It will operate at a higher level, making it more portable across different environments. So that's kind of where we're trying to move things. We're kind of mostly at NFV today, and that's great. It works great. It's deployed widely, but there's some movement and interest in going towards cloud ready and cloud native. So we're looking at things that we can do within DPDK in such to get us there. Okay. So if we kind of step back and look at a service mesh concept, if you're familiar with Kubernetes and such, they already lay out a kind of a container framework in how to lay out and deploy your services. So as an example, a service could be something as very simple as an IMS, instant messaging system, that gets deployed within a container environment. And so what gets defined in that kind of environment is a pod or a collection of containers. A services could be running within that collection of containers. And then another little concept that kind of gets thrown in is what we call a sidecar. A sidecar is really a service proxy, is kind of what our view of it is. And you can use that sidecar as a way to allow the containers to connect to the outside world or provide a service or a construct. Why does it keep going blank? Am I not, oh, I got to move the doggone mouse, sorry. I didn't realize it's going to sleep on me. But anyhow, so the sidecar really is providing, it acts as a proxy. And the proxy could be a proxy to the outside world in terms of like the platform and the underlying protocol infrastructure for that platform. Or it could be a security proxy, as an example, in terms of determining how two different pods or two different containers are allowed to communicate with one another. So there's different things that the sidecar can achieve. Wow, why does it keep doing that? It's doing it up here too. So anyhow, so that's kind of, and with service meshes, right, it's not only providing a mechanism on a single node, but also on how you scale across different nodes in the infrastructure. Okay, so given this as a base concept, trying to look at it, what we're trying to put in DPDK or actually add into DPDK to help with this base concept. So what we're looking at is DPDK view of cloud native, right? Is that you still have your standard applications or containers. They could be a virtual machine, could be based on a container itself. You have a DPDK host, and it could be DPDK host based or container based, which is this little box. I wish I had a mouse here. Here in what we call it in terms of creating a trusted sidecar. So and then you still have your standard native DPDK applications that run at the host. So what we're looking at is how we can improve DPDK to act as a trusted sidecar. So developing a base reference or a solution for a DPDK trusted sidecar. So, this would allow runtime dynamic orchestration, so improving DPDK for runtime knowledge, gathering the services, improving DPDK configuration and manageability. That's kind of what we're looking at from that level. Support both virtual machines and containers. It's both sidecar or VM or native host applications. And of course they have access. We're not restricting anything per se, in the sense that you have to go through a DPDK sidecar. Every application, whether it's in a virtual machine or host-based, still can access hardware as they need. So the goal here is to add into DPDK the sidecar to provide the services to the other applications. In other words, to create a proxy for the services running in containers to communicate with other services and also the base infrastructure of the platform itself. Okay, so that's kind of what we're looking at in terms of adding into DPDK for cloud native. Okay, so what is a DPDK trusted sidecar? Okay, so from a sidecar functional, right, is applications or containers. They need to somehow connect to the outside world, right? So looking at the outside world, the virtual machines can connect many different ways. They can connect on VirtIO, they could connect on SIOV as an example to the outside world. What DPDK provides is a great framework for abstracting a lot of that out, right? And so what we would like to look at is providing inside of DPDK the configurability and manageability of the underlying hardware infrastructure to act as a sidecar for virtual machines and applications to communicate to one another. So we're looking at a product that, well, it's actually part of DPDK today as a separate application. It's called Software Patch Panel as part of this trusted sidecar. In utilizing the DPDK knowledge of all the different hardware interfaces, such as NICs, Quick Assist technology, virtual Ethernets, MIMIF, VirtIO, in such a way that all these ways to connect virtual machines to containers, virtual machines and containers to the outside world, DPDK can act as the underlying framework to abstract all of that out and allow the application to work at a higher level. And that's what we're looking to do, right? So there's, and then the sidecar will provide the, connectivity between the different platform services that are running on the platform, okay? So what are we looking to add into DPDK? There's primarily three different things. First is a runtime coordination. We kind of call it runtime coordination. We're trying to think of a different name for this, but runtime coordination, a higher level abstraction layer, API, and also some improvements to the software patch panel. But what is the DPDK runtime coordination is, one of the things we're looking at is how is it better to orchestrate DPDK. If you're familiar, DPDK provides a lot of infrastructure, but it was never really built as a complete solution, right? It was primarily built as a framework or a base library that you would develop your own applications upon. So a lot of the ability to go in and look at DPDK base infrastructure and configure things like memory allocations or CPU L-core assignments or assigning a NIC to DPDK dynamically. Doing these things kind of dynamically was really never built into DPDK. You could do it within your application. So like when you built your application and deployed, it was capable of doing that. But what we're looking at doing is adding in a library, which we're right now calling runtime coordination, and this would be built based on a fuse file system, or basically a user space file system. So what we're looking to add into this is that all the underlying, like DPDK EAL layer, there are a lot of different parameters there that you can use to configure DPDK. Most of them are static today and built when your application is either launched or such. What we're looking to do is add this library API into DPDK that creates a fuse-like file system. So if you're somewhat familiar with Linux prox file system or Linux sys file system, this is actually very similar to that in the sense that the application, as well as the underlying EAL layer and some of the other layers of DPDK, will mount into the file system different things that you can change and improve or modify, basically. And so this is a way that the orchestration can come in and actually control and program and change the underlying configuration of DPDK dynamically, right? So it's trying to add a little bit more dynamic behavior to DPDK that hasn't been there to, and what we're looking to push into the DPDK environment, okay? So, typical file system operations get set, and write, read is what's being built into this, okay? All right? So the next is what we call a service. It's kind of like an application abstraction layer. What we're trying to do is abstract out some of the more complex aspects of DPDK. So, some of these would be, it's kind of just try to make, some of them would be like macros as an example, instead of you having to write down at the lower level of DPDK APIs. Some could be macros, some could be new APIs to bring up a little bit higher level the application's knowledge of DPDK, or required knowledge of DPDK. So in essence, DPDK, the application would need to have knowledge of what's an RTE L core as an example. We would abstract that up a little higher so that it's just, this is just a thread as an example that's running. And the DPDK just has to be, the application or service just needs to be aware of a thread executing. It's just a generic thread instead of, what the heck is an L core, right? That kind of concept, right? So, and then abstracting out some of the other devices, to make them easier for the application to use. So really just to hide the nature of the hardware. If you look at DPDK, it's very the application becomes knowledgeable of the hardware more. And the goal is to kind of bring that level up a little bit more than what's already in DPDK today, okay? And then there's the last piece that we're looking at including is software patch panel. Now, there are a lot of different frameworks that have been put in place for DPDK to try to build out a pipeline, right? Now, an example, there's a couple of them that have been there for a while in DPDK. One other one that's kind of recent is what was in FFGo, and it's really Golang based in terms of trying to build a pipeline in DPDK. Software Patch Panel doesn't try to build a pipeline, but we started this probably about 2 or 3 years ago, is when Software Patch Panel was started. It kind of lingered for a little bit and wound up, but it is on DPDK repository. But it's really more, Software Patch Panel is designed to be a higher level DPDK resource manager, right? To really manage the DPDK resources and provide a management interface. And so it'll act kind of like the underlying framework that will put the fuse onto in order to manage the DPDK resources. So it kind of like centralizes the original concept of SPP was to centralize the DPDK resource management. And if you're familiar with DPDK, it has a client-server model. And SPP was kind of based on that whole primary-secondary model for client-server. And so you create a primary application that controls all the resources on the platform, and then all the secondaries are assigned resources from that. Now, we won't take it to that level where you were forced onto a primary-secondary model, but using the same general concept of SPP in the sense that you have a single entity that's kind of managing the underlying infrastructure resources. And then the application doesn't have to be a primary, doesn't have to be a secondary, it can be another primary. And then allowing SPP to provide the connectivity between all the different primary applications. And that's kind of what, so you'll have a component of the application, whether it's running in the container or running in a virtual machine, that has SPP in it. And from there, you can actually assign the interfaces that component is allowed to use, right? So for instance, a virtual channel or a MIMIF or such, it could be created utilizing this base infrastructure. And so that's kind of the other thing that we're looking to add into this trusted sidecar. Okay. So to kind of summarize, we see that cloud native is an emerging solution space. There's been a lot of requests and interest in moving towards the cloud and cloud deployment models, primarily for ease of deployment and quick rapid changes and such. We created a great foundation with DPDK in the NFE space. And so we want to build on that success that we had with NFE and improve DPDK for cloud native. So we're looking at adding some new APIs, Fuse file system, service abstraction layer, as well as kind of repurposing SPP to make it more applicable to the cloud environment. Create a cloud-native sidecar to facilitate container interaction with physical devices. So try to bring, DPDK, since it's very well knowledgeable of the platform itself, try to take and make a trusted sidecar proxy so that the remaining services can actually use that. And basically create a trusted proxy for containers and virtual machines to interact with other containers in the outside world. And that's what we're trying to look at going forward with DPDK and Cloud Native. Okay? Any questions? Yes?
Are these things open source?
They will be, yes.
They will be open.
Yes, they will. We'll make it as part of the DPDK. We will push it, we will move it into the DPDK repository, yes.
What kind of product it will be like? It will be like for telcos, right?
For what? Sorry?
Or it will be productized, basically. It will be productized.
I don't think it'll be something that we actually treat as a product, right? As in, that Intel treats as a product, right? We will provide it as an open source project, right? And we intend, of course, that it'll probably be more something like along the lines of SPP, or if you're or packet gen, right? In terms of a separate application that's running that we create that's also part of the DPDK repository. Or if you kind of look at NFF Go is also the same kind of thing. So this will be like that. We're trying to create this trusted sidecar within DPDK and provide additional APIs and libraries for others to use in their applications, or they could build on the existing sidecar that we're going to create. Yeah. Yeah. Any further questions?
Describe how this architecture that you laid out would relate to a cloud-native architecture where I'm allocating devices through the container networking or Kubernetes device plugin. It seems like an alternate model.
Well,
also,
yeah.
The second sort of part of that, if I have a DPK sidecar, if I'm cloud-native, I probably have other services like an Envoy sidecar. We're starting to talk about multiple proxy models, or how does that work?
Okay.
If you could just sort of position it.
Yeah, sure. So yeah, exactly. So So it's not really that we're looking to replace Kubernetes or anything like that. You can think of Kubernetes as more as the orchestration for it, right? So we're creating a sidecar that will, take advantage of the capabilities of DPDK, adding you additional performance, the support for, wide knowledge of platform resources and platform optimizations, that kind of thing that's the main goal. And what we see is this providing over, say, if you just created the sidecar within a container on Linux, as an example, right? So yeah, we're not really trying to push, an alternative model to something like Kubernetes, but this could actually run within a Kubernetes type of environment. I'm sorry, what was your second question?
You're not addressing certain proxy services like
Correct.
telemetry, policy,
Right.
some security models. Those are typically in a sidecar.
Yes, that's correct.
So are we talking about multiple sidecars?
Not necessarily. No, I think what well, okay. So the question is there are different things that exist within a proxy, right? So it could be security. And such, right? That the proxy actually offers policies, that kind of thing. Well, I wouldn't say that we're not adding that, right? We may not have that kind of functionality as a first part of the DPDK sidecar, but the goal would be to that we could offer those kind of services, right? And so they could be separate proxies, of course, but in general they may be wind up as one proxy that's handling that. So as an example, like if DPDK has control over the interfaces on the platform, right? So acting as pull mode drivers, then you would want that application to act as the security proxy to who has access to that. So if you go back to one of the previous slides, a virtual machine can have access directly to the hardware, right? You want someone to have the control over that as a proxy, as an example, right? And so we're kind of looking at how we could integrate that kind of technology into DPDK. I think initially, right, our goal really is to build into DPDK sorry, I don't have it on this slide, but like, the underlying APIs first, and then whatever we want to build in terms of on top of that, to act as the proxy, providing the services as you suggest, then we would add that into it afterwards. But we're trying to look at what's underneath inside of DPDK base infrastructure that we need to put first, but then this proxy could act as the thing, the security, the policy enforcer, that kind of thing. Yeah. Okay, any questions?
Do you have plans of doing any FPGA-based acceleration for this cloud-native side proxy?
Oh boy. Yeah. So I part of my effort for the past 2.5 years has been FPGA, and actually acceleration of virtual switching on FPGA. So absolutely, I wouldn't say at this point that we have anything clearly defined in terms of adding FPGA and FPGA acceleration in, but things like crypto dev, which we do have actually already, our own quick assist devices, they're already part of DPDK, and they could be services or that are offered to virtual machines through a proxy like this. Yeah. Yeah. Okay. Any further questions?
You can repeat it for the recording. Are we looking at the public cloud platforms as well, like Amazon?
Are we okay? So the question is are we looking at the public clouds like Amazon? At this time, I couldn't tell you for sure. I'm sure they could run there, but it's not something that we're really targeting at this time. It's primarily looking at creating, again, a base infrastructure to simplify and help with cloud native deployments. Yeah.
Is there any effort to integrate DPDK with service meshes like Envoy and Istio?
So the question is there any effort to integrate DPDK with Service Envoy, is that correct? Yeah.
There's a service mesh
Oh,
sidecar.
okay. Sure. As a service mesh like on the sidecar as an example. So yeah, sure. Again, it could be part of the underlying Kubernetes infrastructure, right? And we're not tying it to a specific implementation, but it could act as a sidecar for a Kubernetes-like deployment. Yeah. Okay. Any further questions? Okay. Sounds good. Thank you. Not done yet.
Not working. Let's walk upstairs. Great. Thank you. You're welcome.
Yeah.
There we go. No, I didn't. All right. Yeah, good evening, everyone. My name is Nick Davey. I'm a product manager in the SDN business unit at Juniper. And today I'm going to talk to you about the Tungsten Fabric project, which is the open source SDN solution supported by Juniper and others in the community. Tungsten Fabric has a broad ambition of being a very widely applicable open source SDN solution. We don't want this to be kind of pigeonholed into one orchestrator or another. We want it to be broadly used in both private and public clouds, VMs and containers, and to deliver both connectivity and ubiquitous security. Some broad goals and lofty language on the slide, but hopefully after tonight's presentation you'll understand a little bit more about the way we try and deliver on that message. I'd be remiss if I didn't talk about first the code in the community, because if nothing else, I have two objectives. It's first to get you interested in the solution, interested enough to try it out and to use it in your own projects. And second of all, to get you even more interested enough to join our community, to participate as either active users, talking about your use cases and shaping the direction of the product itself and the project itself, and maybe even to contribute some code. Just to dispel a couple myths right off the bat, Tungsten Fabric and its commercial commercial equivalent inside Juniper Contrail, is a completely open source project. So it's an open source core. The code is maintained in the community by the community, and Juniper is an active contributor. We brought our Open Contrail project, which I'm sure many of you are familiar with, into the Linux Foundation. And that, more than anything else, streamlined our governance and made it easier for the community to have an active role to ensure that Juniper isn't dominating the conversation one way or the other. Everything from our bugs to our blueprints is maintained in the community, so I encourage you to take a look at our blueprints in Launchpad to see where we're going, to participate in our Slack channels, and of course to jump in and join the community. We went through a little bit of a community reboot this year, so we're still trying to encourage folks to join that new rebooted community, and we really do want to emphasize that it isn't just Juniper and a couple other vendors or Juniper customers in the room. And yeah, check out our community online, our Slack channels, jump in, participate, ask questions. Just having more voices, more use cases, more input helps steer the project in a direction that's more broadly usable for the participants and your customers and projects. We have a very active community right now. We encourage a lot of the commercial Contrail customers to hop into the community as well. Obviously, a lot of SDN projects have stemmed from some early day lab efforts and some experimentation. We like to view the community around Tungsten Fabric as taking those lab efforts into the broader audience and having a kind of a more open discussion about what people are using SDN for in this day and age. More than anything, Tungsten Fabric and Open Contrail before it have demonstrated this steady progression, this push from labs and trials into POCs and then further on into production. And we've built out from kind of our platform, our fortress of private cloud and OpenStack to attack multiple different orchestrators to be more relevant in different use cases. And it all really did start out with telco, NFV, and service chaining. How do we replace those big monolithic appliances and create more software-driven services in networks? We didn't really appreciate maybe the grandiosity of the challenge, taking a fridge-sized appliance and try and boil it down into one or many more common off-the-shelf servers. So a lot of the early day development work around Contrail went into things like scale, performance, taking that centralized state that normally lives inside of our appliances or inside of our services complexes and distributing them out amongst the SDN control and data plane. From there, we started experimenting because we tend to do a lot of work in the lab ourselves with some of these new ideas that were bubbling around, things like containers and Kubernetes. And those slowly grew from POCs and just lab work into production-ready deployments. So with our 5.0 version of Tungsten Fabric, we now have kind of a strangely shaped solution, one that's good enough for distributing the workload of a gigantic network appliance across many virtual network functions, as well as a solution that's equally applicable to connecting fleets of tiny containers across distributed cloud resources. Tungsten Fabric aims to deliver so much more than just basic layer 2 and layer 3 switching. When we distribute our monolithic appliances out amongst many network functions, we need to provide things like effective and predictable load balancing. We need to provide distributed security policy enforcement because we've just, by replicating our services infrastructure, we've made our attack profile much broader. So we need a way for our security policies to follow our workloads and to apply themselves where our workloads go. Analytics is a part of every single SDN solution. It's a huge part of Tungsten Fabric, so everything that we do needs to generate lots of telemetry and analytics information so that we can see our real traffic as it moves amongst all of these distributed workloads. Just because we're sharing flows amongst a set of 300 devices doesn't mean that we shouldn't be able to pick out one of those flows and gain a great deal of information about it, right? We can't scale out our troubleshooting, the way that we scale out our workloads. So that still has to be very centralized and easy to query and troubleshoot. And of course, because ultimately everything that we do has to make its way from lab into production, we need the ability to do this all in a high availability, kind of seamlessly upgrading fashion. So for those of you who are not familiar with Tungsten Fabric, I figured I'd do just a brief update of what it is that we do and how it actually delivers value. So first of all, we've traditionally been a hypervisor-based SDN solution. We're now a hypervisor, container host, and public cloud-based SDN solution. And we build overlay tunnels. So we're an overlay SDN solution. We build overlay tunnels in order to ensure a clean separation of underlay and overlay state. It also means that we can dynamically shift around our service endpoints without wondering how the infrastructure is going to react to that. So we don't need to worry about things like convergence as we move workloads and services through our various data centers. Instead, the overlay keeps track of where the service is and directs the traffic there. The other kind of interesting thing about Tungsten Fabric is that we're a flow-based or flow-aware SDN solution. So we keep track at a very granular level of all of the types of flows that are coming into the interfaces that connect to VMs and containers. Now the important thing about that is because we have flow awareness, we can do things like flow validation to make sure that these are flows that are conformant with our security policies. We can do very rich load balancing that's done in a resilient fashion. So we'll map flows into a services complex, and we won't move those around if we scale in or scale out our services complex. How that really works in a specific scenario, I always beat up on the 3-tier app because I think the 3-tier, the web app and DB is a really common framework to visualize the impact of SDN. First of all, because Tungsten Fabric acts as that first hop forwarder in an orchestrator container solution, that really means the VMs and containers plug right into our vRouter component. So that means any traffic, whether it's going to an adjacent web server in the same network or into a different virtual network, we have that same ability to control the flow of traffic and enforce security policies. And that lets us achieve microsegmentation by applying security policies even within the same virtual network. And that prevents the spread of, say, malware or just configuration mistakes, really constrains the blast radius of an individual service. So we can make sure in the case of my completely contrived 3-tier web example that my front-end web servers in the green virtual network can't communicate amongst one another. Now, as I'm moving traffic through my virtual networks, as I'm sending traffic to my app backend, I also have the ability to enforce security policy. So I can again say through network policy that these two virtual networks should be able to communicate with each other. That's all well and good, but by having that full flow visibility, I can then secure that traffic to ensure that only the application traffic itself should be forwarded. Finally, when we're moving traffic between virtual networks, we're not a typical longest prefix match router. Instead, we can override those forwarding decisions and reroute traffic to special instances, our virtual network functions. And this is the typical service chaining example where we say we override the routing table to steer traffic through a firewall before we let it go between virtual networks. Because we're using the SDN controller to make this decision, we can scale in and scale out our firewall services complex, and the SDN controller and the data plane will be responsible for making those load balancing actions. Find me the right healthy firewall to send this traffic to, and it'll sort out the rest. What's critical, and why I started out by saying overlay-based SDN solution, is if we look at that big jumble of compute resources that's underpinning all of this, we didn't really need to worry about which container host or hypervisor is running our workloads. Instead, we let the orchestrators place that workload on the most optimum compute or container resource, and the SDN controller keeps track of where those resources are supposed to be running, instantiates their virtual networks, applies their security policies, and then forms the overlay mesh. So your data center can start moving back to a more traditional style of purely routed set of simple devices, or even if you want to go totally wild, just VLAN 1 everywhere, right? We don't need to worry about a lot of complexity or state in the underlay. Instead, we can contain that all in the overlay. What this gives us, especially in modern application deployments, is the ability to completely abstract away from the underlay. That means that we're not talking about a set of switches and routers anymore. Instead, we're talking about maybe a set of internet links. As I start moving my containers into AWS or GCE, I don't need to worry about what compute host is running my virtual router data plane. Instead, I just need IP reachability. So again, it reduces the requirement for connectivity and delivery of services to just being able to ping the far end host, and the vRouter data plane looks after the rest. Again, as my workloads move around, my security policies move around, so I don't need to worry about putting a lot of state and security into my public cloud infrastructure. I just need to make sure I treat it like my underlay, make sure that all the endpoints can talk. Just blowing out the architecture of Tungsten Fabric for a second, we have the traditional SDN-like architecture of a separated control and forwarding plane. So in the middle is our controller infrastructure, a high availability cluster that runs our configuration, analytics, and control plane. Speaks a set of traditional networking protocols. With the Juniper person on stage, I'd be remiss if I didn't say it runs BGP. It runs BGP to interface with external networks, for example, to advertise connectivity, as well as it can offer up BGP to workloads. That's not really the important part. The important part is that it speaks the same set of protocols that your data center and edge firewalling infrastructure speaks today. So there's no new encapsulations or different protocols that you need to speak to interface with the controller. Focusing on the data plane for a second, in each of the compute or container hosts, we run a vRouter data plane. And this replaces a lot of the internal machinations of the hypervisor or the container host. Things like Linux bridges, the traditional routing stack, IP tables. All of these functions are still there, but just not used by VMs and containers that are connected to Tungsten Fabric. Instead, we look after all of the forwarding and security policy application. And the vRouters themselves communicate with the controller using XMPP to download all of that virtual network configuration and security policy information. Kind of used as more of a rich update mechanism than BGP. We can't speak BGP everywhere. Believe us, we've tried. To the actual developer, so what do we expose to our end users and customers? Obviously, there's a UI. There's also a set of REST APIs that you can use to programmatically instantiate connectivity. And then, depending on the orchestrator that we're running in, we expose Heat APIs. We'll listen for Kubernetes API calls. So we'll react to the orchestrator as well and expose a set of native APIs for the orchestrator to instantiate connectivity and security policies. I wanted to drill down for a second on that data plane element because I think it's really powerful that we have a software accelerated data plane living inside of each one of these hosts. This is what really lets us control the flow of traffic to apply security policies and to establish those overlay tunnels. This is really what makes it work. But obviously, there's no one-size-fits-all when you're attacking both container workloads as well as virtual network functions. We need the right way to deploy the vRouter to address each of these scenarios. So the first is cheap and cheerful kernel mode forwarding. Works great in the public cloud, works great with containers, and very few modifications required to run the kernel module. Basically, we leverage DKMS to get the right kernel module for the version of kernel running on the actual host. We insert that kernel module, and then you're off to the races. Contrail can then communicate with, Tungsten Fabric can communicate with the control plane and instantiate all of the virtual networks required for that individual host. That doesn't quite cut it when we're dealing with tens of thousands of connections per second or multiple gigs of throughput. In that case, we need something like DPDK to allocate dedicated forwarding CPUs to give us that closer to hardware deterministic forwarding profile. DPDK has done a fantastic job of exposing accelerated networking to virtual guests, but we are always in a bit of an arms race with the application and service owners who want to drive more bandwidth, more connections out of the same set of hardware. Right now, our go-to mechanism for that is by exposing SRIOV virtual functions to high-performance data plane guests. But again, not every guest in a deployment is going to be high performant or need that high performance data plane. So for lower speed interfaces like signaling, management, basically anything that's not in the direct path of the subscriber service, we can still leverage the SDN features that we lose when we use SRIOV. And yeah, sorry, I should have called that out quicker. When we use SRIOV virtual functions, we're of course bypassing everything in the kernel. That means, or kernel and user space, going right to the hardware, which means we don't have any of those SDN features anymore. We need to make that up some other way. Thankfully, a lot of our data plane instances are quite simple. So in some cases, we can get away with it. In other cases, we're back to our original way of solving problems with lots of complexity and state in the underlay. Finally, something that we're working with folks like Intel as well as other hardware vendors is the FPGA accelerated SmartNIC topologies, deployment modes. And this is where we gain the best of both worlds. We have almost direct access to the hardware from the virtual guest provided by the SmartNIC or FPGA accelerated interface. But we still get access to that SDN overlay with the actual data plane of the SDN solution running inside of the FPGA. This is an area of active development right now, both inside Tungsten Fabric as well as elsewhere. Focusing on containerization, because this has been a hot area of development for vRouter, and just like the previous discussion about accelerating sidecars, there are real needs to deliver highly performant networking into a container environment. Right now, a lot of the reasons to deploy SDN in containerized environments is agility, flexibility, mobility. As our container workloads move around, we don't need to worry about updating our underlay. We don't need to worry about adding more state to the network. Instead, the SDN just looks after that for us. As we start bringing these solutions out into production, we're going to have more and more requirements for high-performance containers, and that's where we can leverage a purpose-built data plane like Contrail to give us both the flexibility of SDN, but the performance of a production-ready data plane. So in a Kubernetes environment, the vRouter runs on each of the container hosts. It provides all of the traditional pod networking, deployed without any configuration. It looks and smells like any other CNI solution. What it offers is that, first of all, overlay topology hiding. So we don't need, underlay topology hiding. So we don't need to worry about all of the switches and routers that our container hosts connect to. Instead, we can use our Kubernetes manifests to specify connectivity and security requirements. It also provides all of those kind of telco-esque features that we've relied upon when we're scaling out virtual network functions. Things like reliable load balancing become absolutely essential as we're distributing our application using Kubernetes. One critical element to the Tungsten Fabric Kubernetes solution is that we implement the network policy framework. So you can use Tungsten Fabric to control the flow of traffic into and out of your container services in both ingress and egress directions. So this, more than any other reason, if you're looking for a reason to play around with Tungsten Fabric in Kubernetes, if you're looking for something that can implement network policy and provide overlay tunneling, this is a fantastic reason to kind of take a look and see what the solution looks like. one element of the solution I didn't really harp on a lot about and didn't feel really relevant, I guess in retrospect it does now, is that Tungsten Fabric is fully multi-tenant. So for every tenant or project, traditionally inside OpenStack, but now just generally, we would create a set of virtual forwarding and control plane partitions, so that all of the reachability information, all of the security policies for an individual tenant are completely isolated from any other tenant. This becomes really useful in either multi-tenant Kubernetes environment where we're providing, say, like a platform as a service to multiple departments or even multiple customers. Also, it acts as a really great guardrail if you have multiple deployments in your environment to ensure that one can't muck about with the other. The traditional way of achieving this in Kubernetes is using namespace isolation. I always like to think of namespaces as more like folders in a file system than the brick wall surrounding, or the walls and the moat surrounding a castle, right? It's really meant to allow you to have overlapping resources. It's not meant to create isolation between those resources. So my Kubernetes namespace lets me have two services called web, but they can communicate freely amongst each other. And if I want to prevent that communication, I need to use something like security policies or firewall rules. In the Tungsten Fabric solution, we have the ability to create custom isolation based on tenant policies. So we can say, for example, just a really easy and convenient way to create multi-tenancy. Every namespace now creates a new tenant. Every namespace creates a new fully isolated partition. So now that namespace kind of acts the way I think we all expected it to. If I place two things in two different namespaces, they cannot communicate between each other unless I allow it via policy. That's not security policy, it's not a firewall sitting in between them, that is actual network reachability policy. And then I can further use my security policies to isolate those workloads or control the traffic going into and out of them. So that was just a brief overview of kind of what we've been working on, where we are today, and what we can do. I'm going to spend the rest of this presentation talking about what we've been up to. So what's coming in the latest release of Tungsten Fabric. The first thing is we took care of a little bit of technical debt that we've been holding on to since our 1.2 release. We completely redid our architecture to move all of our critical components into containers and adopt a microservices architecture. The reason that we did that was to give us better deployment, more access to deployment frameworks, as well as more predictable deployments and easier lifecycle management. In the containerization space, a huge focus for us in this release was the implementation of a rich network policy. So we have the ability to provide ingress-egress network policy, as well as flexible selection of ingress controllers. So you don't have to take the HA proxy that we ship out the door. You can swap out HA proxy for Nginx or for traffic or for whatever project that you like. F5. And then on the NFV front, we've been challenged by a lot of the carriers to talk about how we can now realize the NFV ambitions that we've all been talking about for the past couple of years. Virtualized evolved packet cores have been in lab trials and deployments for a couple of years now, and are slowly making their way out into production. And now we're starting to be faced with a challenge of, well, how do we actually get production traffic through this instance? How many of these instances do I need to achieve my traditional subscriber level? It's one thing to say that we can just scale out more and more instances, right? And that's totally fine. We can have 255 servers performing a job, but we need to make sure that we're getting the most out of those servers. It can't be kind of a linear scale, or else this whole thing, the CapEx numbers just don't make sense. So the first thing, starting with kind of the boring stuff first, the containerization of the Tungsten Fabric control plane, the adoption of microservices. This was a huge effort for us. It wasn't necessarily exciting. It doesn't expose a lot to the community right away to play with, but it was really important because it lets us move forward faster. By shipping our components in containers, we no longer have that whole dependency issue that complex software deployments have. We don't need to tell our users in the community that you need these X number of packages at this specific version in order to deploy the software. Instead, we can ship that all as one atomic container or set of containers and keep all of that complexity inside of the container images. The other neat thing that we can do is once we're inside of a container is we can benefit from container orchestration. So we can plug the Tungsten Fabric control plane into Kubernetes, kind of a Kubernetes on Kubernetes style of deployment, to make use of things like rolling upgrades and rollbacks and staged rollouts. And that just makes the management of a complex system much easier. It also means that we have that big rollback button. If a software deploy does not go well, we can rip the entire environment back to the previous known good version. We also have much better tools to work with containers. We can plug into a lot of neat frameworks like Docker Compose and Kubernetes Helm charts to give a much more scripted deployment experience and one that, again, kind of doesn't expose as much risk to the operators who are deploying it. We've adopted Ansible as our kind of de facto or our default deployer as well. So the goal is to take that Tungsten Fabric deployment experience and really boil it down to the most simple set of primitives possible and to make it as easy and fast and replicatable as possible. And time permitting, I'll show a resource at the end that everyone can take a look at if they want to try and test drive this and kind of benefit from these efforts. I've been kind of dancing around this point. I don't feel like I've made it very well, so I apologize. But the two different phases, the two different types of deployment in a typical Tungsten Fabric scenario are really, really, really big. These are the virtual firewalls that sit in front of the mobile services complexes at all the mobile vendors across the US and Europe. These could be the organization firewalls. Gigantic, what used to be gigantic campus firewalls are now virtual instances running in servers. These have very, very, very different requirements than the managed containers running inside data centers and public clouds. So really we need a solution that exposes that same common set of network behaviors and primitives across both of those environments. The way that we've done this is by exposing a common set of security primitives and frameworks from Tungsten Fabric. So we want to try and take the security out of the underlay, out of the edge, and out of the middle boxes and put it into the SDN solution so that the infrastructure, the data center switches and firewalls or public cloud gateways don't need to have as much service state so much as they need to just permit two things. Communication between all of my compute resources and access into the actual services themselves. Nothing about any of the transactions between the apps in the middle, and nothing certainly that should change as I scale in or scale out my deployment. So obviously in OpenStack, we have made extensive use of security groups to provide distributed stateful firewalling for all of our OpenStack instances. In Kubernetes, we've now adopted network policy as our way to expose that security framework. So you can, again, take the security policy for your workload, attach it to your Kubernetes manifest, and that will instantly turn that vRouter in the container host into a stateful firewall. So now I don't need to have a gigantic stateful firewall sitting in front of all of my workloads. I can have that distributed across all of the vRouters, instantiated whenever a workload is. Of course, we work with other orchestrators like Mesos as well. And we have a netconf transformer that can even transform those firewall filter, or in those security policies into firewall filters applied to bare metal switches. The goal is to have a single programmatic API for you to push your policies into, and it'll just follow your workload, those policies will follow your workload around as you move them from cloud to cloud, container to VM, or even connect them to different bare metal switches. On the other side of the spectrum, we have the virtual network function enhancements. So a lot of this is being driven by VPC. A lot of the vendors that we're working with are still struggling with the challenges that come with delivering high subscriber counts and high throughput entirely in software. The go-to answer for this is to leverage SRAOV virtual functions to connect those service functions into physical networks. So you just bypass all that software mess in the middle, let the traditional switches and routers handle it. We don't need to worry about scaling our software as much. The downside, of course, is now we lose all that magic of SDN I've spent the last 20 some odd minutes talking about. We don't have load balancing, security policies, or that programmatic instantiation of networking. So now I have to deal with it again. I'm logging into switches and routers and firewalls, and I don't want to do that anymore. For the brave few that have stuck with us along this journey, we've managed to profile their workloads, to optimize our forwarding, and across our 3 major versions, we've demonstrated a 3-time improvement of flows per second, or connections per second. This is completely aside from any other work we've done. This is just raw optimization, not new features, but really just improvements. Now, there's only so much you can optimize before you start getting diminishing returns. And really, when we look at the problem of a traditional we'll call it service head-end instance, like a PGW, or even a gigantic firewall, there's not a lot of actual fine-grained state or subscriber information required. So what happens if we start ignoring some of those granular details? That's what we call a fat flow. So flows that aggregate themselves. Yep.
So 3x improvement, is it on a particular hardware or a scenario, or is it in general?
So unlike for like. So if you were to take, at the time it would have been OpenContrail 2.2, and run that now with Tungsten Fabric 5 on the same hardware, you'd see a 3 times performance increase.
So it's like across Contrail versus Tungsten Fabric.
So it's just the evolution of the software and the enhancements of forwarding, right? So this is if you take the same hardware and were to test one version against the other, you would see a 3 times increase.
Okay. Another question is, and it goes back to one of your previous slides, and you mentioned it here also, that Tungsten Fabric, you're dealing with flows, right? So is that something, a feature that you can turn off, or you always do it?
Right, so it is completely controllable. That's kind of where I was trying to get to, was that you don't always need to know everything about the flow. Right at the edge of our solutions, our service stacks, whatever we're delivering using our SDN, I need to know everything about the flow so that I can do things like load balancing, I can do security policy enforcement, I can even traffic steer that into certain service instances based on that flow information. At the service instance, I don't care as much about the individual sources or destination or source ports. I have macro actions on those instances. I take traffic in from one side, I fire it out on the other side. There is some logic in that service instance that controls what happens in the middle, right? But the SDN at that particular instance doesn't care. So
We don't get an analytics record anymore for every flow, so our network could be harder to troubleshoot now. We also can't perform granular traffic steering because we don't have flow awareness anymore, so we can't say this flow goes there versus that flow goes here, right? So it's always, and in everything, with any complex tool, it's always important to figure out what the right set of optimizations are for a particular deployment, and to use those optimizations selectively.
So
Oh.
I have a question. So since you mentioned 5 tuple here, can I classify flow based on something else, like I don't know, VXLAN header, for example, or another customized header if a customer needs?
So Long answer, absolutely. There's the ability to program flow masks in Tungsten Fabric at a very basic level. And that's really what we're doing here is we're taking some of these common flow masks or some of these options and we're exposing them, bubbling up those options to the interface and the APIs. But that type of customization is really low-level work in Tungsten Fabric. And if anyone's interested in doing that, I encourage you to join the community and talk to us about what that use case looks like inside of Tungsten Fabric. From the high-level interface and APIs, no. It's just the fat flow options that I've outlined here. So depending on what types or kind of what parts of the packet you're looking to match, it could be work done in the underlay or the overlay. Like, for example, just not to attach to it, but VXLine is one of those. In and of itself, it is a kind of an underlay transport or an encapsulation header. It's not something you generally see inside an SDN tenant network. But as we have tenants who start building networks on top of networks, we're going to need the ability to control that overlay traffic as well. So it's definitely something that I see us looking at. That's really it for me. That's my gigantic big improvements for VNFs, my tiny small improvements for containers. What I wanted to end this with was kind of a call to action. Through that containerization and lifecycle automation improvement that we've done, we now have the ability to throw up a Tungsten Fabric demo in about 10 minutes on an AWS, or if you point your AWS account at this automation script. Please check it out. Try out Tungsten Fabric. It by default deploys I think it's a 3-node Kubernetes install with Tungsten Fabric. So once you run through the automated installer, you can just start throwing manifests at it and see what your workloads look like with an SDN overlay. So check it out. Jump on our Slack, join our community, tell us what you thought about it and how we can improve. And with that, are there any other questions?
So I saw your the languages used was included C++. I mean, what I knew it was mostly written in C++ earlier on, but I saw also Go involved in there. So what part of the code are there in Go now?
So we have. We've traditionally been a C++ code base. I knew someone would ask about Go once I threw it up there. The first thing that we're optimizing using Go is our middleware API server, which interfaces with our UIs, APIs, and backend components. This is kind of a trial to allow us to see how the code base changes and what we get from moving over to Go. And then we're going to listen to our community members to see how that's received and see if we need to start rewriting other elements of the software in Go.
Yeah, just a basic question about this platform. So this platform contains the controller as well as the virtual hardware.
Yes.
And how do you release all this software? Like, you have model to release all together, you separately have releases for the controller and the virtual. I mean, yes, I'm just curious.
So, that's the product manager hat for a second. There is a loose coupling between the controller APIs and the data plane. So, for example, in upgrade scenarios, we can run different versions of the controller and the data plane, or different versions of the controller, kind of amongst the cluster. But it's always been small deltas, and we don't have always perfect backwards compatibility. So right now we ship everything together as a monolith, controller and data plane, and the only time we really recommend folks run different versions is if they're in an upgrade scenario. That said, if you needed to run for prolonged periods of time with different versions of controllers, this is where BGP does help out because it boils all of that state down to a very simple set of primitives, prefixes, and communities, and can exchange those back and forth. And that's a very well-defined API that works wonderfully across versions. So right now, big monolith, but if there's something weird you're looking to do, it might even work.
Can you please comment on the kind of performance issues you ran into when you tried to containerize your network functions?
So containerize the network functions? Was the question?
Yeah. Initially started with the monolithic application. Now we started, breaking into well-defined functions and then containerize them.
Oh, okay. So the control plane itself. All right.
And data plane also.
Yeah, so Dataplane still by and large doesn't run inside of a container. The Dataplane agent runs inside a container. Dataplane agent's responsible for interfacing with the controller, downloading configuration, producing analytics. That was fairly low-hanging fruit, no real performance impact or difficulties there. Speaking on behalf of the hundreds of developers who are involved in this, and this feels disingenuous to represent their interests, but I'll give it a shot. When producing a microservices-based architecture, you have a lot of complexities in the interactions. What used to be a tight coupling of systems components are now broken apart to communicate over a network or a set of IPCs. Maintaining consistency at first became a really big challenge as developers started kind of iterating over the components. We didn't have that strong set of APIs between kind of internal to the system. So taking an established product or an established project and creating a microservices infrastructure exposes all of the nasty stuff you've been hiding inside of the code base. I think that management of all those separate components is really the hardest problem that we face.
Another quick question. Can you please comment on the kind of work you are doing with the Smartick-based? I mean, you said you are working with the Intel FPGA NICs. Can you share some information what kind of work you are doing with those?
Yeah, absolutely. So working with Intel and other hardware manufacturers, what we're trying to do is take that vRouter component that traditionally runs in either user space as a DPDK application or in kernel mode, and we're moving it into the FPGA. So the entire data plane runs inside the FPGA, and the actual agent responsible for configuration and state management lives outside in the hypervisor still and communicates via some kind of path. The goal would be to move everything into the FPGA so that it is completely freestanding. Right now, there are still challenges that we encounter by having those two components, the software paths for first packet lookup and the hardware path for known flows. So really what we'd like to do is bring that together so you have a fully contained SDN data plane element inside of the network interface itself. For performance reasons, that's fantastic. For me personally, it's portability that's the big seller. In massively shared tenant networks where your consumers shouldn't be exposed to any element of either the underlying hypervisor container host and certainly not the SDN, the FPGA and SmartNIC-based approaches are really the cleanest separation, where you can just spin up something like a VirtIO interface to a virtual guest. It doesn't need to know that it's being backed by an FPGA, right? So that isolation and portability I see as some of the biggest reasons compelling us towards SmartNICs and FPGAs.
Yeah, there are other open source SDN efforts going on for a long time, like you say, OpenDaylight SDN and whatnot. So question, how you compare with both SDN, this SDN? Plus, are there any efforts thinking to bring all better things together from all these SDN different kinds?
Yeah, absolutely. I think the biggest differentiator between Tungsten Fabric and a lot of the other SDN solutions was our adoption of overlay technologies right from the start. We weren't an OpenFlow-based solution. We didn't interact with underlay resources at all. We didn't even fiddle with switch configs or gateways or anything. It was completely overlay-based. That has turned out to be a very, very good delivery model for a lot of services. Of course, there are drawbacks, but a lot of advantages as well. Really, we've taken our initial approach, we've found use cases that work for that approach, and we've honed our delivery of those use cases to the point where we're deployed in many production networks, both as Tungsten Fabric as well as the commercial components as well. In terms of harmonization, I think that's kind of constantly going back and forth in the community, who does what and how do we talk to one another. So in the case of projects like OpenDaylight, We have had some success integrating as a Dataplane element in a broader OpenDaylight deployment. So it's all about finding the right set of complementary features between all of the solutions and using them together the right way. Just like I was talking about, the containerization of the Tungsten Fabric control plane means that we can plug it into a container orchestrator like Kubernetes. That's a little bit chicken and egg if you're trying to use Tungsten Fabric to run your Kubernetes SDN, right? So there's always room for other solutions that provide different styles of deployment or different architectures. For example, in a very simple control plane only Kubernetes deployment, I don't need a lot out of my SDN, but I still need programmatic instantiation of networks. I need my IPAM functions. I need just reachability and stretch for my pod networks. So there's room for other SDN solutions to attack different use cases, right? I hope that answered your question. Spawned another.
So between the commercial container solution and the Tungsten Fabric, what is it that
So thank you for asking. Great question. Always comes up. We don't have a secret hidden repo where we keep all of the good stuff. We do everything right now on the mainline branches in the community. So right now, there is no Delta. There will be some changes in the way that this works going forward, but again, that Delta will be kept very small and will follow common open source methods, when you've got a commercial product and an open source project all based off of the same code base. So it'll be around value add, commercial support, and additional applications and features built on top of that open core model.
So I'm sorry if I missed that. Did you have a slide on the different contributors to the code?
My gigantic banner slide, I had that right at the beginning.
Ah, okay. I'm sorry. I knew I missed it. Okay, yeah.
Yeah, so this is where, as an open source project, we do have some advantages having a commercial component as well, because it allows us to approach more traditional businesses and customers of Juniper's who are interested in SDN and walk them through that journey. A lot of these deployments start in the lab, and a lot of these labs start off with OpenContrail and Tungsten Fabric. They don't go away. These folks keep experimenting, keep contributing, and even after those efforts turn into production deployments, the original open source work carries on, right? So we kind of cut both ways. We work with the community to find interest, but we also work with our customers to find members of the community. Any other questions? Awesome. Well, thank you so much for taking the time tonight to listen. If you have any other questions, I'll be hanging around in the back, so do feel free to find me afterwards. And of course, again, there's the QR code. Please go test drive Tungsten Fabric. Give it a shot yourself. Sorry. Should I use some microphones for it? Thank you very much.
Well, we have it working. Thank you, Nick, for this excellent presentation and a lot of interactions. So thank you, audience, for that. Now we have Louis Gomez talk about OpenDaylight. He's a software test engineer at Lumina Networks. He's a member at OpenDaylight Technical Steering Committee and Committee for Integration. So, a round of applause, please.
Okay, thank you. Okay, so yeah, so just to start with, I want to listen to the presentation or okay, let me.
So while he does that, a reminder,
This feedback, survey feedback, if you have that little slip that you got at registration, has a link to the survey. Please go ahead and fill out the survey. We would like to hear from you what you like about the individual presentations, hands-on lab.
What is the
and,
presentation mode?
What would you like to see in the future?
What is this application?
And if you want to contribute to these meetups, engage with us, how, all that. So, yeah. And Ravi Prize at the end.
Yeah, we try to figure out the presentation. This is the PowerPoint or is another application?
This is a PDF.
No, you just open like, but still, why is showing all the...
Oh.
Oh, lower right corner, yeah, probably there.
Yeah.
That one.
Yeah, I don't know how to make that full screen. Whoa, I didn't do it. There you go, and then you can click.
Oh, this one is to move on.
Yeah.
And yeah, that's pretty much it. I mean, any question that you have about OpenDaylight, because I have been working there for a while, but you can also ask. I'm more like a kind of integration test person. I mean, the kind of software I write is mostly test software. So yeah, anything that you may ask about these kind of topics, I can also answer. So yeah, let's start this. So these are the topics I want to cover today. The first one is something called what we call the release streamline. The second is a community. More than a year now, we have this kind of controller kind of architecture. Well, the architecture is very standard. There is the service abstraction layer. You have all the plugins and you have all the application. But you can see the amount of application and components that are in OpenDaylight in this particular release, right? In Carbon release. Now, I'm going to show you this. This is the Oxygen release, which is the version that we just released very recently. And you can observe already some difference from before. And this is the new release that we are planning for, for Fluorine. This is for after summer, right? So you go back and then we replay this again. You can see here, then you can see here, and now you can see here. So do you see any difference? Well, there are different. The main difference is that you can see there is a really streamline in terms of application, plugins, something we are releasing together in OpenDaylight. So this is a huge difference, right? I mean, there was a time in the OpenDaylight where every release were multiplying the number of applications, the number of contributions. That at some point got a peak. And then after some time, probably Carbon release, like more than a year now, it was the other way around. The trend was actually to get less application, less contribution. I mean, at least in terms of the software components. Now, what is the explanation for this? Right, so as an open source community, there is an explanation for this. So the explanation is, well, you have here, like OpenDaylight is already a mature project. I mean, at least now we're running like I don't know, 4 years or something like that. So with all this time, it's like only successful and when consumed project in the end survive. No, this is a real open source thing. Nobody really, try to put things on top of anybody. So in the end, only those applications that have real value, that are really well used by people, by users or other communities, those survive. So that's a normal, trend. The second is that, yeah, we got over time less contributors, so there are less contributors but very focused now. They're in the same exactly trend. No? We have less, but these people, they know exactly what they want. They see the value of some of the application and they put all the effort in this application instead of doing so many things that we did in the past. And then there is also the quality over quantity. No? Even in the beginning, there was a lot of things about, innovation, try to get new things, try to, Now there is a point where we are more worried as a community about the quality of the thing, right? So this thing needs to get into eventually production networks. Some of them there already, and we have a lot of pressure to push the quality over the quantity. So that's also another reason. Now, there is another reason, especially when you saw the last two, the reduction of the projects. The second reason is the managed versus self-managed model. We introduced that we introduced this concept in this release cycle. So now the managed projects, or what we call managed projects, is those projects that have a solid foundation and a healthy community in OpenDaylight. And then self-managed projects are the opposite. So there are these projects that they don't have a strong community. They are not very much well supported, either because they are very new, or either because they are old and nobody really uses them much, right? So for this reason, we are the self-managed. Now, the way we figure out how to differentiate and treat this in the community is that the managed projects will have like 3 checkpoints in a release cycle. And these managed projects are going to be automatically released every 6 months, which is the cadence that we have today. While the self-managed projects today, they don't have any requirement. So you come new to OpenDaylight or you are one of these old projects, you can still, do your own release cycle with no really checkpoint, nothing. And you are your own responsibility. You can release anytime, and then with a few effort, we can include you in the official distribution. There will be always like user information, whether you are a managed or self-managed. So there is a user awareness, whether you are, in which group you are. But in the end, we can release everything as before. But this is a way that we really like, because now the people that we have been working as a community, we focus in certain projects that we know they are important, and then the rest we are still welcome, right? These are open source. We like to welcome new contribution, new things, but they are treating a little bit differently, so and releasing a lot of the common effort that is in the community. So that's really a good model for us. Any question you can take any time. So this is very, Now I'm going to show a community report. Community has, I think this is based in, in some data that, for instance, this one is showing different periods of time. You can see some statistics there. This is from Viteria. So we use Viteria as an external kind of application company that connect to our Gary system, the patch system and everything, and then it's pulling all these statistics and so on, right? So you can see in different periods of time, like what are the number of commits, like how many patches you put in the system, and then how many authors, no? And now you see, this is clear the trend, right? We have to say, while the commits, it didn't really going down, like you have a large, large amount of commits per quarter, the amount of authors now are less. And this is a little bit the trend that I say now. There are now less companies in OpenDaylight contributing, but now they are very focused. So very focused means that maybe the same people or maybe a few new people, they are spending a lot of time in OpenDaylight. And that's why you don't see a decrease on the number of commits. But still the authors or the amount of people that are normally contributing are less today than before. Okay. Affiliation, this is the question. Who is contributing today in OpenDaylight? Which companies? What is this? Well, you can see here this, right? At least in the last report from first quarter of 2018, I think Red Hat is number one. And there was a switch there. So OpenDaylight, you have followed this from the beginning. In the beginning, Cisco was overwhelming. So they have a big majority of developers doing work. Now this changed. Now Cisco have less, and now Red Hat took over clearly here. The Linux Foundation has people also working there, especially on the infrastructure and that kind of things, not really developing the software, but helping in the project. So that's why you see them there. And then you have some companies like Ericsson, I know Saif, HP, Lumina, so still some other, right? Now the priorities. What are the priorities now in the OpenDaylight?
So, a
Yes.
question on the Linux Foundation contribution. So, you said they're contributing on the infrastructure.
Right.
Is this, like, what is the motivation for them to do this?
So there are two reasons here actually. They have an obligation for some of the things that they are doing in infrastructure because they are supporting in Linux Foundation model, right? But actually this might depend on what is your contract with Linux Foundation, but at least the OpenDaylight contract with Linux Foundation is like they take care of the basic infrastructure for all the build system, the test system, all that is that. The infrastructure you need for develop code and testing code, all that is managed by Linux Foundation. I mean, they are the administrator for that. We don't admin that.
That is specifically for OpenDaylight or for the networking projects in general?
I think for LFN is a trend. Like for LFN, I think the OpenFV has some kind of difference because OpenFV they have distributed lab. You have the Intel lab, you have some distributed lab. So because of that system, the owners are really the community members. But in OpenDaylight, the real infrastructure, where you develop your code and everything is Linux Foundation, yes. And then they can subcontract that. Like for instance, now our cloud provider used to be Rackspace, and now we have Exos, a small one. But still, we have, all the resources are hired by Linux Foundation and maintained by Linux Foundation too. Yeah. So, and then there are two aspects here for this contribution this high. One is they are obligated to support us, but the good thing here is that there are some people in Linux Foundation that after hours or in their own free time, they like what they are doing, and so they are doing extra work. So it's not just supporting us, but they are writing more tooling, more feature for our own infrastructure because, just because they like that, and they like to contribute. So this. Yeah, they like the kind of OpenDaylight thing, and the openness, and the feeling, and everything. They do this, and they are not obligated per contract to do all these things, but they do actually. They help us a lot. But it's mostly infrastructure work. Like you have a script to do better tests or to do better building, accelerate this, to do any kind of feature that is related with infrastructure. They also do very, very well, and they are very skilled set there. Yeah. Oh, yeah. So TSC, we did a technical steering committee, is totally meritocratic in OpenDaylight. Some other community that are more recent, they have a system of appointee people, like the members company, they put some senior engineer there. In OpenDaylight, we move, I think, maybe 2 years back to the model with all meritocracy. So you do work in the community, and then there are elections every year, and then you get selected in the technical steering committee. So there were people in the foundation doing so much contribution extra, and that they are now part of the TSC because they deserve it. The technical steering committee, yeah.
So the member companies, do they get representation?
In the past, yes. Now it's no obligation, no at all. Yeah, you need to get selected by the community. You cannot get in the TSC by just appointed like in the past. Yeah. There was only one exception, it was CDE, because they came late in the model, and then they have one person that came just because they were contributing, but they are contributing very much anyway. So
at this moment, they are also, they're represented.
Yeah.
There's no company represented.
Right. So yeah, we can maybe move on. The community goals today, these are some of the discussion we have this release. It's a span contribution based, especially on the kernel projects, right? So we have this thing that we have something called kernel project, which is the framework of the OpenDaylight today. And we see that those areas, there are very few people, very good people actually, very skillful, but very few. So we try to see if we can increase the amount of people contributing in these areas, right? And some of the good idea is reaching the downstream, right? We know OpenDaylight is being used by downstream people, communities, companies. So we try to reach and say, oh, you want this project to continue in a healthy way? We need to get some contribution here, right? This is important for us. The second is to improve the release model, and this we already done by the managed versus self-managed that I explained before. This was very good. The third thing is improve first impression documentation. Well, OpenDaylight has been always blamed by that. like our documentation compared to other open source, maybe not open source, but anyway, it never went very good for the first, user or developer, doesn't matter. When you first see this documentation, you don't feel like very attracted and also very easy to follow. So we are changing all that. Like we already have, for example, a group of people that we are contributing, myself included, in updating all the front documentation, at least for, and I think today the projects are very aware. So today the project, they are producing all the managed that you see there, self-managed is self-managed, but managed project today, they are producing quality documentation in OpenDaylight. So the only thing we need to do now is the common that nobody, does by itself. This is the one that we are improving now. Infrastructure efficiency, well, this is again, we need to, because we have less people and everything, and the project itself needs to be more efficient as well, so we try to also do some adjustment there in number of jobs that we have in the past, reduce all that, and also reduce infrastructure without, impacting quality and things like that. And then we have this, LFM has this push for collaboration, whatever belongs to LFN. So today we have found that we have a strong, at least collaboration with OpenDaylight. OpenDaylight is this project in LFN that does integration and tests of everything. So they are currently using OpenDaylight, I believe some other controllers too, and they do integration with it. So we have some project also to integrate with them. It's not new, so we have in the past release, we started already, and it's things like, for instance, when we release something, or even before release, we pass something to OpenDaylight, they can test, and then we get some feedback. Something is wrong, then we don't release, or things like that, right? And then there is another second integration I was thinking is because they have all the bare metal kind of labs. For some of the testing that we need to do in the controller, we are using the labs that are in OpenDaylight. So there is very good understanding and communication with OpenDaylight, in particular this project. So yeah. Community goals or technical goals, that too. So I put these ones because I think these are discussed and also very important. The first one is very important for us now, the cluster stability. I mean, it has been there from the beginning. Actually, in the beginning, we didn't have any cluster. Then we start to introduce cluster, but it's a feel in the community that we need to improve this a lot. So now there is a lot of effort, not just writing more application, more feature. No, forget about that. Now let's work in the cluster altogether to make this, scalable and stable. The second thing, it's more technical. The Java great strategy. Apparently now Java is releasing more often, so now we need to dig up with that. So there is some community discussion now. Improve developer documentation, the same thing I said before. And then there is a lot of things now to create more tooling, more and more tooling in our infrastructure. This is where these people in the foundation help, but it's not only them. There is people in the companies helping building all this tooling that we need for, especially for fast release and fast verification. This is what we want to do now. And to be honest, all this self-managed and managed differentiation is going to help us clearly to release faster and more stable than before. When you need to watch 50 projects, imagine, now it's only 15 or 20, it's much easier now to release, to coordinate and to get, the thing much easier. Anyway. And finally, this is the use case. So what are we, with all this reduction, right? What are you doing today, right, in OpenDaylight? Well, apart from all the reduction and all this streamline, I will still focus in this, I put just very high level use cases. I'm not going to enter in super details and everything, but this, I put just 3. So the first one is the classic network abstraction, right? So this is, OpenDaylight is just a controller, so we don't, for instance, develop like, a Dataplane. And in the traditional network abstraction use case, what we try to do is to exactly that. I mean, you have a traditional network or white box. This is more the physical network. And then we try to, abstract all this. When you talking about traditional network device, all behave differently. So we try somehow to abstract that. And then from the white box point of view, you can use OpenFlow or some other protocol that is more on the control plane. But still you want to abstract all that information for the application itself. So it's all a network abstraction kind of model. So this is the more basic fundamental use case, right, that you can do in OpenDaylight. Try to leverage all the plugins that we have today. Some examples are put there, but you can leverage all these plugins to run your own abstraction. Now, write your own abstraction or use an existing abstraction. Well, my experience in OpenDaylight is that I had different attempts today to get an abstraction for all this, but it's difficult, no? Because when you are talking with the people carriers, people that really have hardware, everyone has his own opinion, what should be the abstraction level, what is the information that I need from my network, this is important, this is not important. So in the end, I see that all the interface that you see OpenDaylight to existing orchestration or cloud, in some cases is kind of not well defined, and something that you can work with your customer or that kind of things. So yeah, this is the basic use case. Now, going a little bit higher is the data center networking, obviously. So now, what happened with the data center networking, you see OpenDaylight there, is like, yeah, you can obviously write Neutron plugin instead of OpenStack and Kubernetes. I think these are the two that we are focusing today, or we implement today. And then based on that, you can do some networking, right? So this is a little bit this is the data center. But these are, the Kubernetes is recent, so it's not something that we are doing for a long time. The OpenStack one, it has been very old, so it has been from the beginning. From the beginning, we have the OpenStack integration and the OpenDaylight kind of thing. Yeah, and this is a use case that obviously, yeah, many people in community is pursuing this use case, especially the Red Hat and some others, Ericsson, I guess, too. So this is really the use case that they're. The advantage here is the interface. The interface that you see in Northbound is much more well-defined, right? It's not anything. It's something that comes from the orchestration. It's OpenStack or the Kubernetes or something, so you know exactly at least what is the kind of policy, the thing that you need to do. The first use case is more open, but this one is more self-contained, but still you see all the complexity here as well. Yeah. And then the last one is, well, I don't know if you're familiar with this, but this is the ONAP project. This is also in the LFN. It's a new recent project in LFM. It came from, yeah, I think AT&T and some other operators. They actually came up with this big system, super big system. It's a big orchestration, right? This big orchestration apparently can manage any flow that an operator can have today, right? Any workflow as a service provider you can have in your network, you could do through this big system, right? And part of this big system, the ONAP project, is what you see there is the SDNC and then the application control. There are some controllers there for networking. And today, those controllers are based in OpenDaylight. Now, I have to say that all the application that is written for OpenDaylight in this particular environment is done in the project ONAP itself. So we in OpenDaylight, well, we don't hold these applications that are running in this particular environment or ecosystem. So, but I don't know actually there is any strategy at some point to move these applications to OpenDaylight or just leave them in the ONAP project. But yeah, it's true that they are using there and there are requirements. This is a downstream community for us. It's an open source community, so there are requirements that eventually come to us from them, like, at least from the platform point of view. They develop application, but from the platform point of view, we have technical requirement, clustering, resilience, all these kind of things coming from there. And I think that's it, because this is that was the
So then there are two different projects now on OpenDaylight? One just maintained by ONAP?
No. So ONAP is a downstream community that it holds the application code for the SDNC application, all the application that you can see here for controller. I think the two in the middle, I'm not sure about the third one, but at least the AppC and the SDNC, all these applications are today OpenDaylight based. So they use the OpenDaylight platform with the plugins and everything, but then they write their own application in the platform, right? So the model is like, yeah, they consume, whenever we release something, they consume whatever plugin things that, because OpenDaylight is modular, no? You will release something, but then you can choose which components you can do. So they choose the component that they want to use, and then the application that they write in OpenDaylight is done in this project. It's Java, it's still compatible with everything that we do, but it's done in the context of the ONAP project. This is a little bit this is the downstream company, like Lumina, my company, right? So we get the open source platform, and then we write our own application. Some of the application, because they are customer specific, or because whatever reason, we write ourselves, and then we wrap all together, right? So this is the same model. They just take the platform, they write their own application for ONAP. This is just ONAP, and then they just ship it all together, right?
And they're open source.
Oh yeah, this is full open source. There is very big project here.
So that code is available through the ONAP.
Yeah, so all this SDNC code, yeah, for control is available through ONAP, not through OpenDaylight.
In that case, in that sense, there is another file.
Right. Yeah, so there are two projects. Yes, if that was your question, what's the OpenDaylight project, the upstream project in this case, and then the downstream project consuming the OpenDaylight is the ONAP project. Yes. Yeah. Yeah.
There are other efforts going on now.
Go ahead.
Stack-on C4 might offer interface between white boxes and SDN. Stack-on might offer the efforts are going on in the form. So are you part of it?
So yeah, I think the question that you are asking if we are part of the Stratum project, or we have any kind of interaction with them. I don't think that is happening today, and I think the reason is, I mean, my understanding, because I'm not even part of any politics here, I'm just an engineer. My understanding is that Stratum is first targeting switch vendor, white box vendor, right? It's not really controller. The really focus is to get the hardware, the silicon that are to be more open and implement new interfaces. It's very, actually I was looking at that, and the standardization body or the kind of scope is pretty good, because it's not only the control plane that they did in the past, like OpenFlow and that kind of thing. They also want to do the management plane. So they want to standardize everything, that any communication that goes to a data plane, they want to standardize in this project. And they have the Google support, and they have some other stuff. So I think it's good, very good, but I think for us it's a little bit early for the controller to be part of this. I mean, there is also, you read about, it's like, in order to do integration of these new interfaces, they already have the ONOS controller, which is part of the ONF as well, so part of the same kind of ecosystem. So they can leverage for free the controller they have there, at least for this initial integration of the interfaces. And then later on, when these interfaces are well defined, I mean, the body standard and everything apparently is not well defined yet. They're working on that, so it's nothing really well defined today. If you are part of the switch vendor and then you start contributing, no, I mean, I don't know, there are some price to contribute for sure, but if you are a member there, you get access to all this standard, and then you can contribute to the standard, and eventually you do an early implementation in your switch of this interface that could be, good for you. I mean, for OpenDaylight, I had to say that the only thing that I know is that CT, that is part at least of the ONF, if I remember correctly, they were trying to bring the P4 runtime into OpenDaylight. So that's why they have a project there, because they are collaborating in this project with ONF, and they have some access to these interfaces and everything. So they were trying at least to get the P4 runtime into OpenDaylight, but now we don't know anymore because CT has some issues itself now. So, but yeah, I mean, we are not very concerned now anyway, because we think that this thing will come naturally. We don't need to really push for that. Whenever the standard is there and everything, we will try, I mean, naturally people, if they are interested, they will bring this contribution in OpenDaylight. The good thing with OpenDaylight, in my opinion, is it's a really truly open, free, open source community. So tomorrow anybody say, oh, this is interesting, I want to bring this with no issues, no money up front. I mean, that's how it works. Yeah.
In fact, those efforts involve all the way from switching a 6 to all the way getting STM controllers.
Yeah. So what was the comment?
In fact, those efforts involve all the way low level, all the way from switching a 6 or switching hardware all the way to STM controllers.
Yeah.
I have a question about, you said ODL integrating with, in terms of CI/CD with OOTBND. So what are projects from OOTBND that's integrated?
So OpenFV this project is all about it's all about installers and integration, right? You know, it's installer for, well, I don't know nowadays actually, but at least when I was following OpenFV, it was mostly installers for OpenStack and this, you know, for cloud installer, right? So you install your OpenStack system, for instance, and then, I don't know, it's probably more than OpenStack today or even that. But still, it's all that is around your cloud infrastructure. It's an installer for your cloud infrastructure, private cloud infrastructure. So for that reason, OpenDaylight was seen like any other controller as part of the cloud infrastructure, at least on some of the applications that we have, like NetBeard or some others. And then because, yeah, it's exactly this picture. So this is exactly the picture that is being tested today. I mean, it's integrated as part of a installer and also is tested in the OpenFV environment, right? And I mean, you probably know more.
They are having some projects which are like, there's one project called SDN VPN which integrates with the network project in OpenDaylight, and that's one thing. And the second thing we are looking into is leverage the OpenFV hardware labs also. That's the thing that we are looking into.
Yeah, that too, yes. I mean, so yeah, so I don't know if the question was more about collaboration, because we had two components with OpenFV. They are consumers of our product, not in the way of an app. An app takes our platform and write their own application, and that's part of their deliverable. For OpenFV, they are not writing any application. They just take whatever we give them, right? And then they just do some installation packaging for it, right? So they can package this together with any, you know, OpenStack, whatever system they have there, right? So that's what they are doing today. Now, that's the delivery or the release kind of interaction. But then besides that, the one that I mentioned before with the CI/CD interaction, we are two communities, so we are collaborating each other, like, you know, getting all this process in place. They give us some hardware access. We give them access to, you know, very snapshot or very, you know, very early releases that they can test. So all this kind of, you know, yeah. Any question? Well, thank you very much, because I know this is hard. I mean, this time age already. I mean, seeing still people here is really. Thank you for staying. No, right there. Okay. Oh, here? Oh, okay. Thank you.
Thank you.
Thank you. I appreciate it. All right.
Thank you. So Michelle is coming for the most fun part. For everybody here who stuck around, we have some fun prizes. Is the survey still open?
The survey is still open.
Okay.
I thought maybe we could do the registration drawing and it's closed.
Yeah, so just take a few minutes to fill out the survey. The little slip that you got when you registered, that has the link to the survey. Okay, so we are going to do the registration drawings first. Let's do the other drawing first. We'll do the home.
Okay, so Rob L. from C2M.
Is Rob here? Rob L.
Paresh
Harish S. Broadcom.
Oh, Mark Isakara?
Mark Iskra. Gone. Oh. Devekar Kiran, Calsoft. Ah, okay.
Okay, so I'll close this.
So the survey is closed now. Yeah, let's do that. So while Michelle pulls up the survey results, anybody having birthday in June? No. Anniversary? Huh? How many times you have come to this meetup? More than 3? Oh, there are a lot of people. Okay. let's up it now. More than 5. 2 people. Okay, they deserve it. Please come. I'll give 2 water bottles. So Michelle has a random generator app here.
JN.
Yay! So this is the $50 Amazon gift card. There's some more prizes. Oh, 2 more.
Oh, we could do that, sure. Yeah. Just pick up the survey. Yeah. Well, the next one was 4. We'll just use these 4.
Yeah. Tuan?
Okay, last one. Is Cindy still?
Is that
Cindy.
Seely?
Oh, you are still here, I think.
Oh, cool.
That's good. The registration is good. I think they are.
Thank you. And now, everyone's picture. Group picture, please.
Everybody to the stage.
Come with your prizes.